You are going to die. You have always known this. Every human who has ever lived has known this. It is the one fact so obvious, so ancient, so sewn into the fabric of existence that most people stop questioning it before they are 10 years old. You age, you slow down, you stop. That is the deal. But what if it isn't? What if the people alive right now, not your grandchildren, not some distant future civilization, but you, the person reading this today, are the last generation for whom aging is simply accepted as inevitable? That question is no longer science fiction. It is a serious research agenda funded by billions of dollars, staffed by Nobel laureates, and driven by a growing scientific consensus that aging is not a law of nature. It is a process, and processes can be interrupted. Your body does not have to age the way it does. That is a strange sentence to sit with. Here is what aging actually is. At the cellular level, your body is a machine that makes copies of itself. Every time a cell divides, it copies its DNA. And every time it copies that DNA, something is lost. On the ends of your chromosomes sit structures called telomeres, tiny protective caps, like the plastic tips on the ends of a shoelace. Each time a cell divides, those caps get a little shorter. When they get too short, the cell stops dividing. It becomes what scientists call senescent. It does not die. It just sits there, releasing toxic signals, telling neighboring cells to slow down, inflaming the tissue around it. Multiply that across trillions of cells, and you get what we call getting old. That is not destiny. That is chemistry. In 1984, a molecular biologist named Elizabeth Blackburn discovered an enzyme called telomerase, a molecule that can rebuild those shortening caps. She won the Nobel Prize for it in 2009. The implications were immediately understood. If you could activate telomerase in the right cells at the right time, you could potentially slow or even reverse one of the core mechanisms of aging. You could, in theory, keep the shoelace tips intact indefinitely. But telomeres are only part of the story. Your cells also accumulate damage over time in ways that have nothing to do with division. Proteins misfold. Mitochondria, the energy-generating engines inside your cells, become dysfunctional. Metabolic waste builds up inside cells faster than it can be cleared. Your immune system, which was once a precision instrument, starts attacking your own tissue as it loses the ability to distinguish friend from enemy. These are not random insults. They are predictable, measurable, and increasingly, they are being targeted. In 2013, a biologist named David Sinclair at Harvard Medical School published research suggesting that aging is fundamentally a loss of information. Not genetic information, but what he calls epigenetic information. The DNA in your cells does not change much as you age. What changes is the way it is read. Imagine a book whose letters stay exactly the same, but the punctuation slowly disappears. The sentences stop making sense. The chapters blur together. That is what happens to your cells. And if that is true, Sinclair argues, then aging is not the inevitable corruption of a machine. It is a software problem. And software can be rewritten. His lab has already demonstrated this in mice. In 2020, Sinclair's team published a paper in the journal Nature showing that they could induce age-related vision loss in mice, and then reverse it. Not slow it. Reverse it. Using a cocktail of 3 genes delivered directly into the eye, they reprogrammed retinal cells to behave as if they were young again. The mice could see. The epigenetic noise had been cleared. The punctuation had returned to the page. Let that settle. They reversed aging in a living mammal's tissue. And mice are not the only place this is happening. A company called Altos Labs, launched in 2021 with over $3 billion in funding, backed in part by Jeff Bezos, has recruited some of the most accomplished biologists on the planet for a single purpose: cellular rejuvenation. Not treating diseases of old age. Rejuvenating the cells themselves. Turning back the biological clock inside living tissue. At the same time, a researcher named Aubrey de Grey has spent more than 2 decades arguing that aging should be classified as a disease, a curable one, and that the first person to live to 1,000 years old has already been born. Most scientists find that number provocative, but fewer and fewer find it entirely impossible. There is also the work being done on senolytic drugs, compounds designed to hunt down and destroy those toxic senescent cells, the ones that stop dividing and sit there poisoning their neighbors. In clinical trials in humans, senolytics have shown the ability to clear these cells from tissue, reduce inflammation, and improve physical function in older patients. They are not a cure for aging, but they are the first drugs ever designed to target aging itself, rather than any single disease it causes. Your body has a self-destruct mechanism built into it, and scientists are learning how to turn it off. Now here is where things get genuinely strange. For most of human history, death from old age was not even the norm. Your ancestors, the ones who lived tens of thousands of years ago on the African savanna, rarely died of aging. They died of predators, infections, starvation, childbirth. Aging was almost irrelevant because almost no one lived long enough for it to kill them. The evolutionary pressure to maintain your body past reproductive age was essentially zero. Natural selection had no reason to build you to last. You are not falling apart because nature intended you to. You are falling apart because nature never bothered to fix it. The biologist Peter Medawar described this in 1952 as the mutation accumulation theory of aging. Genes that cause harm late in life, after you have already reproduced, are invisible to natural selection. They get passed on without penalty. You are, in a very real sense, carrying biological time bombs that evolution never diffused, because it never had to. But here is the thing about evolution. It is slow. Science is not. What took 4 billion years of random mutation to build, a focused human research effort might be able to modify in decades. The tools now exist that did not exist 20 years ago. CRISPR allows scientists to edit specific genes with a precision that was unimaginable in the 1990s. Machine learning systems can analyze the epigenetic profiles of thousands of cells simultaneously and identify patterns of aging that no human researcher could detect alone. The sequencing of the human genome, which took 13 years and $3 billion to complete in 2003, can now be done in a day for a few $100s. The pace of change is not linear. It is accelerating. And so we return to you. If you are under 40 today, you are statistically likely to live into the 2060s or 2070s at a minimum. That is 40 to 50 years from now. The scientists working on aging believe, not hope, believe that within that window, some form of meaningful life extension therapy will exist. Not immortality, not yet, but the ability to slow, pause, or partially reverse the biological aging process in humans. What does that mean for you specifically? It means the contract you signed at birth, the one that said you get roughly 80 years if you are lucky, and then you fade, may be renegotiated. It means the question of what you want to do with your life may need to be asked differently. Not, what do I want to do before I run out of time, but what kind of person do I want to become across a much longer arc than anyone has ever had to plan for? It means the grief you carry for the people you have already lost, the ones who did not make it to this moment, is a grief with a particular timestamp on it. They were born just slightly too early. The Austrian philosopher Ivan Illich once wrote that the desire to eliminate death is the desire to eliminate the human condition itself. He meant it as a warning. Others hear it as a description of exactly what they are trying to do. Neither camp is entirely wrong, because alongside the science sits a set of questions that no laboratory can answer. If death is optional, does life retain its weight? If you can always have more time, do the choices you make today matter less? If aging ends, does meaning end with it? These are not hypothetical philosophical puzzles. They are practical questions that a generation alive right now may need to actually answer. Your ancestors did not ask what they would do with 500 years. They asked what they would do with the harvest before winter. You may be the first humans in history who have to think differently. And here is what makes all of this so difficult to hold in your mind. You still wake up every morning in a body that aches a little more than it did a decade ago. You still watch people you love get sick. You still live inside the old contract, even as the people trying to void it are working in laboratories right now, tonight, in Cambridge and San Diego and Tokyo and Zurich. The future is not here yet, but it is closer than it has ever been. You are going to die. That is still true today. But for the first time in the 4 billion-year history of life on this planet, that sentence comes with a footnote. And the footnote reads, probably, unless the people in those laboratories figure it out in time, which means the most radical thing you can do right now is something your ancestors never had to consider. Wait.